As the plan gets to be end of Monday, two classes out, schedule's gonna go over the next 3 days. We'll do 3-6 today, 3-7 and 3, I'll cut out for right now, we'll figure out something we'll do a little later. For right now, your test will gonna be up to 3.6 and we'll have that on Monday. With that said, we don't know, probably. I usually, time for both.
Usually I fix them. We're gonna do more word problems today. All word problems today. Let me. Let's do. Let's do. Six, no, so it's 3. There we go. All right, then I'll throw a few of the mixed ones up here. This will be for your benefit. These come out of 3.4. Any one of these could be a test problem, so this is very good practice. So there's the schedule for the next few days. I'll adjust the syllabus and things like that after class, but go ahead and give that one a try. you think you got it, let me know. I'll come around.
I think they got it. What's wrong with when you set up a way like this? You split up a quantity into two pieces. Describe both pieces. Formula for the interest is this. P is the principal, R is the rate, and T is the time. But in this problem, time is 1 year. So all of these, that T is going to be 1. We're just I is an equal PR in this problem. So the amount of interest, so principal times the rate is how much interest that's earned. So interest. So I don't, X is the amount I'm gonna let be the principal at 4%. So P is X, and there's the rate. And then you've also invested the other amount at 7%. That's where you have your principal this time is 20,000 minus X. Is 7%. So you can see in each case, that's a P and then it's an R. P, R. Total interest, which is what they want. That's where you add the two of them together. That total amount of interest is 1100. Problem. Now let me convert all those percentages to decibels because they're undesirable. Percentages. So 4% is the same as 0.04. 7% is the same as 0.07. Also, I seem to like the decimals in front of them instead of to the back of them. I'm going to distribute the 0.07 through. So that's that after I distributed it. On the left side, the only things I can combine is the 0.04x and the negative 0.07x. So together, they give me a negative 0.03x. We're almost there. Next, I'm going to subtract the 1400. Finish it off, I'll divide by negative 0.03. Find the x, which is the amount that we put at the 4%, was $9,000. So $9,000 was invested at 4%. How much was left over for the other one? Because they started with 20,000. So they invested 11,000 and 7%. All the mixture problems are nearly identical to this style. So in all of them, you're going to have to give a handle on this stuff, breaking the quantity into two pieces like that.
Gonna try another one? All right. All right, it's all yours. I don't have a sign. Sorry. I don't have a sign. Oh, yeah, sure.
Do it. What do you got? 6,000 Jack. And they want to vote. But what do you have to do about what you done? Yeah. So 4 pounds?
Mhm.
4 pounds down there, 6 pounds of jelly beans, that you guys got? Here, it looks like jelly beans are more expensive than gummy bears, I don't think that's really true. But I could be wrong. I honestly don't care. But let's go here and see, it's the same setup as before. Here, let's say X equals the amount. Gummy bears, maybe that's a better word. That forces, since we're using 10 pounds, 10 minus X would be the weight jelly bean. Remember, you ought to take that and multiply it by the rate. So everything in this section is like this. Everything is a P times R, some number times a rate. So I'm gonna take X, what's the rate for the gummy bears? The gummy bears is 240 a pound. So there's the amount and this is the rate. Because it says 240 per pound. And then the amount of the weight of the rest of it, jelly beans. Jelly beans, oh, I must have said that wrong. Jelly beans are cheaper. Okay. Jelly beans are $1.60 a pound. So this is an amount times the rate. And we know that we're going to get something that's cost $1.92 a pound. Get 10 pounds of that. I personally don't care about the decimal, so I'll just multiply everything out by doing this. So I'll rewrite that as just 2.4x plus 16x, 16 minus 1.6x. Then I just got to move the decimal over 1, 19.2 that side. Let me combine those x's. Let me subtract the 16. And then I'm ready to finish it off. I'll just divide by the 0. I made a mistake. Anybody notice it? That's awesome. Alright. The mistake is 2.4 minus 1.6 is 0.8, not 0.08. My answer would be really, yep. Hold on just a second, just stop for just a second. Here's how you can find out you made a bad mistake. If I go and do this here. I'm gonna destroy this. Let's say I didn't notice the mistake, I just happened to notice it right now. Take your calculator and tell me what you get for X. $40. Now, how many pounds do we have in candy? sense that our answer should work. Something wrong there, isn't there? So I happened to notice it before I got there. Let me fix my errors. 0.8x. So I'll get my 0.8. 0.8. We see that x equals 4. X was the weight of the gummy bears. So 4 pounds of gummy bears. All right, and how many pounds then would there be of jelly beans? How do you get that? Right, 10 minus x. Right, one of them was 4, the other one is 10 minus 4, which gives you 6 pounds jelly beans. You know, I solved that like that. What? Why do you say anything? That's fine. So what if the answer come out? 70. You will do it if you're. That won't work. I think that. So you can. 10. 2, 6. Divided by 6. 2. Okay. I'll just leave it at that. This is a pretty standard way of doing it. And more importantly, though, even though you do have different methods for it, it's the fact that they're all following a certain order. Right. Understand this? Get a hand on the fact that all of these problems are all of this form, and practically all of them do something like this, break something up into 2 pieces. If you get a handle on those 2 things, you can go on those word problems easily. All right, one more, and I'll move on to 3.6 because I want to do a lot of those. I don't know. I do not know off the top of my head if I will be able to. Let's try Molina and see what happens with Molina. Well, I can tell you in a minute. Hold on. Yeah, let's see. This is a problem like you've had. Here's what I'll do. I'll give you this one. This is one out of the book, and then I'll make up one just like it that will have decimals and things like that. Hopefully, I can do these 2 things before the class. The first half is over here. So go ahead and try this one. First, before you do anything, can you tell me, if you read the $7,500 is being broken into 2 pieces, can you tell me what the 2 pieces of the $7,500 is broken up in? What are you going to call them right off the bat? What's that? Sure. $7,500 that she's investing some into one and rest into the other. How much do you want to say she's putting in 4%? What do you want to call that quantity? Since you don't know. About X. How much does that leave? 0.5%. X minus, not X minus. 7,500 minus X. So some is X and the other rest is 7,500 minus X. Those are your two amounts. pricing the X of the amount at 4%, how much was there and percentage? Samples, how much is left over for you? No. They're investing $7,500. Oh. Putting some of it at 4%. Saying is how much is left over for 2.5%. So this whole thing is how long? How much does that leave? So X was invested in 4%. Estimate. Was invested in 2.5%. Total amount there is $225. I'll turn these percentages into decimals. Distribute. All right, next what I'll do is I'll combine my X's. Subtract the 187.5. And then I'm ready to finish it off by dividing by the 0.015. Zero. And this turns out to be 2,500. X was the amount at 4%. Dollars to invest. You put $2,500 into one. That's 7,500. No, I think I did because I had a problem while we were doing this one, and it all 10,000, and I can't get out of my head. Right, it'd be 5,000. 7,500 minus the 2,500 would be 5,000. That's at the 2.5%. Nobody is. I'm not sorry, wasn't 100%. It's all the problem. It's just taking the work. Oh, yeah, that's what everybody says. The equation is the hard part. Yeah, exactly. Well, of course, yeah. Once you get the, because we've done a million of those kind of problems. And they're pretty mechanical. Logic. Steps. But, and be that as it may, the next hour is even more word problems. I don't know what you gotta do, go out and get yourself some coffee or something, come back in 10 minutes and try to be refreshing. It's difficult to teach when nobody gets any of them. You imagine being a comedian and just sat there and looked at you. Anyways, come back at 2 o'clock or 2:02.
No, the test will be Wednesday. Wait, what did I do? Yeah, what did I write up there? Let me check that out. I have to do a review. I don't think I did. Today, okay, yeah, that's right, because I'm not doing 3.7 and 3.8. That's right, yeah. Okay. What have we done up to this point? Sure. You can look in Blackboard, you can look at old tests and things like that. They're there from before, you know what to expect. 100. Yeah, I'll put them in, I'll do an update every test. Homework overall will end up being about 10% of your grade. Yeah, you can redo it, but if you do it after, any stuff that you do after the due date is marked off 10% automatically. Well, of course it is. So if you haven't done it, 0.9 is better than 0. I'm sorry, I didn't hear you. Yeah, I think I put all the rest of the homework due on that same day.
guys ever heard of the term unit price? Store at your shop. You ever notice those little stickers underneath of the thing you buy off the shelf that has some sort of a price per pound? That's called the unit price. So the unit price, if we take this thing right here, for the unit price for that thing, we take $8.48 and divide it by 30 pounds. Use your calculator to get that answer. So I'll take the 848 and divide it by 30. Now, you might need to go, I think 3 decimal places will probably be good. What we get for this is approximately the following. I get 0.283 dollars per pound. That's the thing that they put on the little sticker underneath of the price. Or it's along with the price on the sticker. That tells you how much it is, what is it per pound. Calendar is way, way more expensive. So we obviously try to compare some jobs. The idea here is that you're not saying which one is better or which one's worse. You're considering these to be the same, and you're just trying to make a financial decision on which is the better deal. So I would like to find out the unit price on this guy. Can you guys get me the unit price on this second one? $12.98 divided by 50 pounds. And approximately, if I go to 3 decimal places, I actually get 0.26. I have to. 0.2596. So that 6 will round that 9 up, which will force that 5 to go to 6. But I don't care about that. That actually is not as important as what I'm going to use. Which of these would you purchase? Which is the better? You're paying about 26 cents per pound for the heavier one. That's usually the case. When you buy something at a store, if you buy the larger quantity, it's usually cheaper to do it. So with cat litter, this here is the better deal. You get the idea. This is the unit price. Similar to what we were doing before, except now, well, I'm creating a rate. This is a rate because it is something per pound. To play the role of like an R, future problems. Let's try another one then. Let me give you another one to try. See if you can do this one. Same deal. Give me the best deal of the 3 ones listed. All right, do that for me. Tell me which one is the best deal of the 3 of them. I think 3 decimal places are what they do at the store, so I think that's good enough. If you go to Walmart, just check it out. Go to Walmart. I bet they go to 3 decimal places. Actually, you have to go to as many decimal places as you need to determine which one's a better deal. I'm gonna do like I did last time, 3 decimal places. That much for the first one. 0.229, 228, sorry, 0.228, did you get that? But you round with 3 places. Yeah, no round, if you're gonna do 3 decimals, round it. This is 0.22. My bad. So round if you're going to 3 decimal places. See what the next one was. This next one, I get 0.212. My last one, I got 0.218. Best deal of the 3. Middle one, isn't it? A little more than 20 cents per pound. There's our best buy. Any questions? This is something you've probably done in stores your whole life. I'll let you have a preference for whatever the product is. That's a different question. All right. This is a different style of word problem than we've had before, so let me talk about it. What you're going to do in this thing is set up a proportion. That's where you set up 2 ratios and you set them equal to each other. So here's what I'm talking about. We have by the cost of 3 scars, 2 scars cost $29. So what you can do is set up an equation like this. So what I'm talking about here, if you look at this, I know that 2 scars is $29. They want to know what the cost of 3 stars is. So they want to know what would go in that spot down here. Seen these problems like this before? The way you solve them is the following. I multiply these 2 quantities together to get 2x. Then I multiply these quantities together to get 87. I'm going to drop the dollars for now because I don't know what to put at the end. Have you seen that kind of a solution before? What do they call that kind of what do they call that kind of multiplication? Name for it. It's not true. It's totally true. Did you say? I thought it was asking for the price of 3 and 2 cost. Minus cost of 3 scars, right? Yes. So 2 scars cost $29. Right. So how much does 3 scars cost? $42.50. Oh, 87, 3 times 29. 1450, okay. Now, X is just the cost of three of them. X is not necessarily the cost of each scarf. So let me divide. Because X is equal to 43.5. Says. And so the spot that goes down there is 3 over 43.5. So the cost of three of these, 43.50. That's what the question was asking. So this is a famous kind of a problem. What they call this multiplication here, have you heard the phrase cross multiplication? That's what it is. Every time you see a proportion, you should probably automatically think of doing this cross multiplication business. Questions about this? I think the idea here is to get through as many of these things as I can before the end of class. Give you as much chance of doing these on your own. All right, go ahead and try that. Anybody think they got it? 2. They give you the ratio. How much? So they tell you that the ratio of salt to baking soda is 0.75 to 1. So they tell you that salt, baking soda, 0.75. Salt. What do they give you? The salt of the baking soda. So I think it's better to put it in 1.5 teaspoons, and then B will be the amount of baking soda that I want. Cross multiply. So this gets multiplied to that. And you get 0.75 B. So then 1 times 1.5 is just 1.5. Obviously, they call it cross multiplication because, well, it looks, see, there's a cross on it. Divide by 0.75. Divide by 0.75. And B is equal to 2. Since we're talking about teaspoons, then we need 2 teaspoons of the baking soda. So I was wondering, I always make recipes. Did you ever see her doing the stuff off the out to the side doing these things that she makes them?
Let's try another one. Let me go up to 52. Kind of jump. I don't know how many do we have here. I have way more than I need. Okay. Okay, go ahead and try that one. Whenever you travel to a foreign country, one of the first things you have to do is exchange your money to their money.
Here, I would set up a ratios that was British over American. So the BA, they give you 100 British pounds was the same as 128.7 American dollars. But now they go, what if you have 280 British pounds? How many dollars is that in American? This is the way you guys set it up. And then just cross multiply. So we get 100A equals, what I got over here was 36036. Then I divided by 100. And so we get A equals 360.36. Now, if you convert it to dollars, all you gotta do is put a dollar sign in front of it. 360.36. Question? Yes.
All right, we'll move on to a different type then. So I think you guys got the feel for this. Let's move on to a different style of problem then. You want to do any of these triangle ones? I could do one. Let's do a triangle one. Just one. These are not hard. The obvious question is to figure out the value of that letter X. That's all the way underneath of the smaller triangle. Right there, that guy. Do you guys know what these mean? These little equals and this little one? Do you know what all this stuff means? Never seen it before? You know that inside of these triangles are three angles, right? Let's look at this angle right here. You guys with me? You see over here? While the triangles are different sizes, this angle is the same. That's why it has the little line through it. While these triangles are different sizes, this angle is the same as this one, except it's shrunk. Same thing here. The three lines means that these two triangles are equal to each other. Well, similar triangles have an incredible property. So whenever you're dealing with one of these triangles, they have corresponding angles. The inside angles are the same. Well, the property that they have is they have, if you have a triangle, say one of them, and then another one, just like we have here. Say you have, this is A, B, and C. But the corresponding side lengths are A prime, B prime, and C prime. All the following equations are correct. I can take this A divided by B. That would be the same as if I take this A prime divided by the B prime. Likewise, if you could help me, if I could use my picture and I were to do B divided by C, could you tell me what it equals in this triangle? Prime divided by C prime. Got it. And it works for all the sides. So in our problem here, I want to involve the X. So I can do like X over 24, or I can do X over 27, or I can have it upside down. I'm going to do X over 24 equals. Now I use this side and this side. Can you tell me what it's going to equal from here? $26, because that's the X one, isn't it? 32 is that side. Those are the corresponding sides. So we have 26 over 32. And then once you got that cross multiplied, you get 32x equals 26 times 24. Watch this. I know you're like, I'm going to do something ridiculous you've never seen before. Check this out. I'm going to divide by 32 now. But over here, check this out. 8 goes into both of those, doesn't it? 8 goes into that 3 times, and 8 goes into that 4 times. I can even do more. Like 4 goes into 26,
13 times 3 is 39. Over 2. So then, what's that, x is 39 over 2. So that's the property of triangles. They're not that bad. They're gonna give you are, these, what do you call them? These, similar triangles. I don't care. It doesn't matter. If it doesn't say, you can do whatever you want. All right, let's pop into here then. These are like mixture problems again. Here's Danica or Danica. I'm not sure how to say it. With money. So anyways, you can imagine she has a collection of pennies and nickels. And she counted 131 of them for $3.43. So how many pennies and how many nickels were in the jar? If I tell you that the letter P stands for the number of pennies, can you tell me how many, using that letter P, can you tell me how many nickels there are? How many coins are there total? So how many are left over for the rest of them? I usually have this thing on silent. There's P pennies. How many are left over for the nickel? Same thing as we would write. 131 things. Cut off X of them. Part of it. What's left for the rest of it? Try again. You're close. Switch it around. Look, if I take X plus 131 minus X and you add it up, what does that add up to be? 131, doesn't it? The X's cancel out. So together they do add up to the whole thing, don't they? All right, so X P, I'm using the letter P for the number of pennies. How many nickels then? Using that idea, how many nickels am I gonna have? So you fill up that file. I wanna know what goes over there. So there's 131 pennies and nickels. Yeah, you get a bunch of pennies. One of them. I mean, pennies and nickels. We divide them up into pennies. Pennies. How many coins are over here? 131 coins total. What's the total of all these coins together? 131. How much that worth? In fact, it's a problem right now. That number is not even existing now. It's not even existing yet. So whatever you say, 3.43 is wrong. In any shape or form. So. All I'm talking about is I have 131 coins. I know they're pennies and nickels. So I know I'm gonna separate it into two files. Pennies and nickels. I'm gonna say there's P of these, P pennies. I'm using this file using the same letter. All right. If I have 131 pennies, how many nickels would I have? 0. If I have 130 pennies, how many nickels would I have? If I have 129 pennies, how many nickels would I have? If I have 128 pennies, how many nickels would I have? How in the world are you getting these numbers? Taking one minus the other, correct? So if I have 127 pennies, how many nickels? 5. All right, I'll keep going here. What if I have 70 pennies? How many nickels do I have? How'd you get that? So how about 71? What do you get then? 131 minus 71. Is that correct? So if I have 72 pennies, how much would be over there? $72, so 131 minus 72, that would equal 50. Possibly, but they're not. They have to follow some rules. You know? Right, it doesn't come in any part yet. So all I'm doing is this, I don't know why, but you guys, you will not do this. What if instead of all these numbers here, I simply put the letter P?
what would go into that spot? What would go there? That would go there? This pattern follows this line, looks like that one and that one? Even that one? This line and this line, do they look like that one? Do I have minus 131 anywhere over there? No. Can you give me the blank spot now? Two quantities, one letter. I don't know how often it comes up every single problem, right? Now I can finally use the stuff that they gave me. All right, so we have 131 coins, it's worth $3.40. Total of pennies. Plus the nickels. Equal to $2.40. How much is each penny worth? Cent. So it would be 0.01 times P. Now, can you tell me how about the nickels? How much are they worth each? 0.05 times what quantity? You're doing it again. What goes in that spot? That's it? Pennies? I don't know if you noticed, but practically every single word problem has come down to a solution. Let me tell you one thing. Mathematicians or math, to me, we've been doing the same problem the whole time as far as I'm concerned. One word problem, the entire. It's the same problem over and over and over again. I'm gonna drop the dollar signs. Oh, by the way, why can't you just put 1 and 5 here for like 1 cent and 5 cents? I'm sorry, why is what I'm asking you. If I wrote it in terms of cents over there, I'd have to change this to 343. Understand? So you've got to either work in all dollars or all cents. You don't want to mix them. So anyways, we have 0.01p. Just multiply this through using the distributive property. I'm not sure what I get for 0.05 times 131. Now, in a problem like this, I do want to ask you, what type of an answer should we get? I mean, do you think that we should get, if I get anything other than a whole number, it's wrong. Understand? The answer is the number of pennies and nickels. And I have half pennies or half nickels like they used to have in those songs that we sung as kids. I got, for the first part, I got 6.55 minus 0.05p. That's equal to 3.4. You can also wipe out all the decimals by multiplying the entire equation by 100. That'll take out all the decimals. Anyways, let me combine the p terms. I've got 0.01 minus 0.05 So of the P's, I get negative 0.04 P plus 6.55 equals 3.43. I'll subtract the 6.55 from both sides. So I get negative 0.04 P. What did you say? Negative 3.12? So I'll divide by negative 0.04. $75, $79. What does that equal? $78. My calculations were off. Now, if I were working on asking the figure, that's what they do in nursing. Every time you get a wrong answer, they fail you on the test. Because they say that you killed somebody. Answer for everything from the best. Right? All right, so 78. So what's the answer to this problem then? Remember, what did the question ask before all this started? You should read the question to know what, I mean, it's a good time to reread it to see what they're actually asking you to find out. They wanted to know how many pennies and how many nickels there were. We've got the number of pennies. That's why using the letter P was a good idea. I got 78 pennies. Tell me how many nickels I'm going to have. So the 131 minus 78 equals the 53. So we have 53 nickels to trade. Now, please, throughout the problems on the homework, I want you to try them. We're going to review next time. But in the word problems, this thing where I take one piece and break it into two and do this kind of stuff with it, handle on that word problem will just fall in front of you. Well, just need a good handle on that. All right, that's all I got for today. Remember the new schedule. Wednesday we'll be review, and then we'll have our first test on Monday. And the test you always take in here. Okay.